In this problem, we're going to go over a very important torque-related problem that has to do with a pulley. So in the first few minutes, for those of you who haven't watched my previous videos, we'll go over a method for how to approach any torque-related problem. So a step-by-step instruction so that you know how to approach and how to start these problems. And then in the rest of the video, we're going to actually solve this pulley problem. So let's start by talking about our method. So as always, the first step will always be the same. We're going to draw a free body diagram, right? Figuring out what forces are present in the problem and labeling the arrows to represent those forces. So maybe an arrow left, right, up, down, or at some angle. We'll have to choose a coordinate system. Typically clockwise rotation means negative and counterclockwise has positive direction. Then we'll have to identify the rotational point. So if the system is rotating, it's pretty easy, right? You know what is the rotational point. If the system is not rotating, you can kind of pick any point as your rotational point. And from that point, we'll have to figure out the distance of each force, right? Because torque is force times distance. So not only do you need the force, but you also know the distance away from the rotational point. Then you apply the second Newton's law in horizontal and vertical direction. So you sum all your x forces, all your y forces, and set them either equal to 0 or ma. Finally, you calculate torque of each force using the equation for the torque, and you sum all these torques essentially together. So you'll have at most 3 equations in total, right? 2 equations for the Newton's second law and 1 equation for the torque. And once you have those 3 equations, you just plug everything in and solve for the unknown. Now, let's take a look how this method applies to solving the following problem. Here we have a pulley where 2 blocks are connected by a massless rope and that runs over a solid cylindrical pulley of mass MP. The 2 blocks are hanging vertically, with the first block having a mass of M1 and the second one of M2. The pulley through which the rope runs has a radius of R and a moment of inertia of 1/2 mr squared. Calculate the linear acceleration, so calculate A as it's released in terms of variables given. Let me get some water. And remember to stay hydrated as you're working through physics. So we're going to have essentially a mass, right? So firstly, we're going to draw a free body diagram as always. So let's start with block 1. Block 1 will experiencing M1, G, and the tension force upwards. On top of that, the second block, right, is heavier. So the whole system will so the block 1 will go, the acceleration will be positive. It essentially will go up because the second block, right, will be pushing on it, is heavier because the second block is heavier. So the second block will have the following free body diagram. The gravity, of course, M2G, the tension force, and it's traveling downwards. So its acceleration is negative. Great. Now let's talk about the pulley. So the pulley will experiencing the following forces. The 2 tensions that are applied to it. And the gravitational force, but the gravitational force will be applied in the center. And as you can see, the point of our rotation of the pulley, it's rotating around its center. So the gravitational force of the pulley itself isn't actually going to make it rotate. So I'm not going to draw it on our diagram since it's not going to contribute to the torque of the pulley. Now, we just talked about that the center of rotation is at the center of the pulley. So the distance that these forces are applied is R away, right? Now, you might be thinking, how come these 2 tensions, right, are not the same? And the reason is because now the pulley is rotating, which means that if these 2 tensions would have been the same, then the 2 forces would just cancel each other out and the pulley would not rotate. But we do know that the pulley is rotating, right? Therefore, these 2 tensions will be different. Unlike our example when we were dealing with just in the units of forces. Great. Now that we have labeled all of the forces and even for the pulley we labeled what is the distance that those forces are applied from the center of rotation, let's write down the second Newton's law. Firstly, for block 1. So block 1, F net is equal to MA. So what is the net force, right? I want you to think about this. it's going to be T1 minus M1G is equal to M1A. What about block 2? So block 2 will have force of T2 minus M2G is equal to negative M2A, right? Because the acceleration now is down, and down we label as a negative direction. So, great. Now, what about the pulley? The most mysterious maybe of these three objects. So, for the pulley, we put the torque equation. Net torque is equal to I times alpha. As we said, now let's also label the acceleration for the pulley. Again, this second mass is heavier, so therefore the pulley will be rotating right in this direction right here. Let's label that as a positive direction. So even though it's clockwise, right? Let's label that as a positive direction. So therefore T2 will have a positive torque because it's in the same direction as acceleration, and T2 will have negative torque. So it's going to be force times distance minus force times distance for the first tension. So again, I summed up the torques from both tensions. The torque from this tension is going to be T2 times R, distance away. And for this one is going to be T1 times R. Great. Now, Li is going to be 1/2 mr squared because we're given that in the problem itself. Now, I can do one more thing. This right here is the angular acceleration, but I need to find linear acceleration. So why don't I try to use the conversion formula from linear to angular acceleration, and I can rewrite alpha as A over R. Then one of my radiuses will cancel out, and my formula will become the following: T2 times A. As you can see, the radius here can be also canceled out because it's in each term. So I essentially, now I just want to combine these three equations right here that I have. Remember when I was discussing our method, I said at most we'll have three equations and we'll just have to combine them together. I think the easiest way to combine them would be substitution. So let me plug in for T2 and T1 from these variables right here. So T1, right, is going to be M1G plus M1A. T2 is going to be M2G minus M2A. So plugging in for T2, then plugging in for T1, this one I called mass of the pulley. Let me open the parentheses, right? So negative right here, this positive right here will become negative. Great. Let's put all the terms that have acceleration in them on the right-hand side, because we're looking for the final formula for acceleration. So here we'll have M2G minus M1G left on the left-hand side, M2A plus M1A. I can factor out acceleration and divide by this big parenthesis, right, on both sides essentially to get my final equation for acceleration. True. And just like this, we get our final equation for acceleration of this system, right, in terms of the variables given. Great. So in the next video, we're going to find out how to solve our first example where there is some kind of angle between the force and the axis of rotation. We're going to go over a very, very typical problem in this unit, which is going to be a ladder that leans against the wall. So I would highly advise you watch that if you want to do well in this unit. Other than that, thank you guys for watching. Keep practicing and keep watching these videos on your way to an A. Thank you.